Okay, so find the Taylor polynomial of degree 3 centered at x equals to pi over 3 for f of x sine x. How would you solve this? You just set sine of x equal to a0 plus a1. If it's centered at x equals to pi over 3, what does that mean?
X minus pi over 3.
X minus pi over 3 is here. And then a2, x minus pi over 3 squared, plus a3, x minus pi over 3 the fourth, the third. And then, by the way, it's impossible for this sine function to be equal to that, right? So you're really saying that it's part of this infinite series, and we just want to find these values a0, a1, a2, a3, and we just want to stop there. If you truncate at the third power, that's called the Taylor polynomial of degree 3. Okay.
Would you ever tell us like bounds?
What?
Would you ever tell us bounds like between sine x between 0 and 2 pi?
Oh, no, that's not necessary because when you find the Taylor polynomial of degree 3 centered at pi over 3, that is only going to be approximating sine x near pi over 3, just by a little bit. So, like bounds really don't matter much. Whether you have a big bound or small bound, it doesn't say much. But I mean, if you're asking this because you've seen this before, there is actually a error estimation if you have the bounds. So there's a way to figure out how large an error would be if the function is defined in this bound and you're considering the Taylor series truncated at some order. Okay? There's a way to compute it. Okay? And yeah, I may or may not cover that. I have to think about that. Okay, so now we start out by doing what? What should we do? Plug in
pi over 3.
X equals to pi over 3. Okay, then you get sine of pi over 3 equals, everything goes away and you just get a0 as pi over 3, right? What is sine pi over 3? Yes?
I do have a question. So
yeah.
in order to even use the equation that for a Taylor series, you have to find all the a's that you gave us, right?
I haven't told you the equation for the Taylor series.
Oh, that thing wasn't the equation that affects?
No, I haven't yet given you the formula for the Taylor series. Okay. Yeah, I'm intentionally holding back the equation from you because, one, it's only useful for some cases. Two, if I just give you the formula, you're not going to understand what we're doing.
But then what was the general Taylor series of that?
That I haven't given you the general Taylor series yet. Yeah.
Oh.
It's not given to you yet. Okay. All right. So what is sine pi over 3?
1? No.
0, right?
Can you just take
Pi over 3 in radians is what?
Radical
it's
2 over 2.
No, pi over 3 in radian. No, pi over 3 in degrees is what?
60.
60 degrees. Right? 60 degrees.
Radical 3 over 2.
And then the height is the sine, right? And it's longer than the other side, right?
Radical 3 over 2.
Yeah, radical 3 over 2.
Because it's equal to 60.
Yeah, because I mean, this side is long, that's short, right? So it's small, medium, large. Small size is 1/2. Medium size is radical 2 over 2. Large size is radical 3 over 2. Yeah. So it's the longer size. Okay. Now you differentiate both sides and you get cosine of x equal to a1 plus 2a2 x minus pi over 3 plus 3 times a3 x minus pi over 3 squared, and then plus dot dot dot. You plug in pi over 3 again. That tells you cosine pi over 3 is? What's cosine pi over 3?
That's 1/2.
It's a small size, right? Yeah. Small, medium, large. So it's positive 1/2. So you get a1 equals to positive 1/2. Okay. And then x, you differentiate again, you get negative sine x equals to 2a2 plus 3 times 2a3 x minus pi over 3 plus da da da. And you plug in x equals to pi over 3 again. And this time sine pi over 3, we know that's radical 3 over 2, so it's negative radical 3 over 2 equals to 2a2, so that a2 would be negative radical 3 over 4. Differentiate again, so it's you get negative cosine of x equal to 3 times 2 times a3, then some other terms where they all have x minus pi over 3 to some power, right? So when you plug in pi over 3, you get negative 1/2 equals to 6a3, which gives you a3 equals to negative 1 over 12. Okay, so you got all the coefficients, and the biggest mistake would be stopping here because you thought you got the answer. What's the actual answer?
You have to put all those
Back into
like a polynomial.
polynomial, right? So the way people write it is either T3 or P3, T for Taylor or P for polynomial. So T3 of x is given as radical 3 over 2 plus 1/2 x minus pi over 3 minus radical 3 over 4 x minus pi over 3 squared minus 1 over 12 x minus pi over 3 cubed. And this truncated polynomial will be a good approximation to the sine x near x equals to pi over 3. Good?